Okay, we are going to start. Welcome, everyone, to the latest episode of Scrubbing the Skies, the webinar series of the Institute for Responsible Carbon Removal. As always, I'm your host, Will Burns, and I'm really glad that everyone has joined us today. Now, as the second edition of the state of carbon dioxide removal revealed, there is an extremely large gap between the amount of anticipated carbon removal over the course of the next couple of decades, as opposed to what has been projected as the requisite levels of carbon removal over that same time period. At the same time, a lot of the assumptions about the amount of carbon removal that's required is premised, especially in integrated assessment models, on so-called hard to abate sector emissions, which falls under the broader rubric of residual emissions. And there's increasing concern that our estimates of hard to abate sectors may be fundamentally incorrect, may be overwrought in some ways, and there may be ways for us to reduce emissions in those sectors in a way that in turn would reduce the requisite levels of CDR, right, which could be beneficial from a standpoint of environmental justice in some cases, as well as helping us in addressing the potential uncertainties about many of these technologies. And our guest today is going to help us sort out some of that. He's done an excellent new study in conjunction with a co-author on the hard to abate sectors, what criteria are pertinent in that context, and in some ways how we might address those issues. And so I want to introduce our speaker, Harry Smith, who's a doctoral scholar at the University of East Anglia. And his paper, which is published in the journal One Earth, is entitled Navigating Net Zero Residual Emissions in National Climate Strategies. Harry, welcome back. And with that, I will turn over the floor to you for your initial intervention. As always, after that, I'll try to seed the conversation with a couple of questions, and then we'll move directly to audience questions. So please start generating your questions for the Q&A box. And with that, it's all yours, Harry.
Brilliant. Well, thank you, Will. It's a pleasure to be back on Scrubbing the Skies, your webinar series. I think we were last on the series back in 2023, early 2023. And of course, CDR being the fast-moving pace it is, a lot has changed since then. So it's a pleasure to walk through our sort of most recent study, which I'll just share my screen. Well, if you just let me know you can see the screen. Brilliant. See the thumbs up. So excellent. So good afternoon or good evening, wherever you are. It's 6 p.m. here in the UK where I'm based. As Will mentioned, I'm a PhD researcher at the University of East Anglia, as the name suggests, based in the east of England, in a very flat county known as Norfolk. But my day job here is to look into how carbon removal is being mainstreamed into climate policy and how it features in some of the reporting under the UCCC and international negotiations. And so, as Will mentioned, this presentation will mainly walk through the paper on the right that we recently published back in May in One Earth. But on the left is our former paper, which we presented on this webinar series back in early 2023, that really explores carbon removal specifically. This latest paper is on the sort of momentum behind residual emissions and what that means in terms of practical climate governance. And so I'm going to start with a trend that will be familiar to many, and that's the uptick in national net zero targets since the Paris Agreement. This is my best attempt at using multiple databases to track the status of net zero targets over time. What you'll see is, of course, this really rapid rise around 2018, but also a very subtle shift, looking at the dark blue and the green here. That's a transition from simply talking about these net zero targets towards placing them and contextualizing them within policy documents and also setting them into law. And these policy documents and these climate laws often contain provisions towards planning different sets of measures and policies towards achieving these climate targets in the long term. So think, for example, in the UK land base, the system of carbon budgets we have in the UK and how that fits into, for example, the UK net zero strategy in turn then achieving net zero greenhouse gases in time. So accompanying that trend of national net zero targets is this trend that follows of policy planning. And this tracks two different provisions, one under the Paris Agreement, known as LT-LEDs, that's long-term low emission development strategies. This is Article 4.19 of the Paris Agreement. They're essentially, these LT-LEDs are the smaller sibling of the NDCs, the nationally determined contributions. Those NDCs steer the near-term sort of project of climate action. These longer-term strategies are meant to be the long-term vision in which the NDCs track onto. And so they're often stretched towards the mid-century or beyond, depending on the timing of those net zero targets. This also tracks another provision known as the EU long-term strategy. These are similar obligation to LT-LEDs, but set about by the European Commission and reported by member states. So it's really part of the EU's formulation of its own assessment of climate progress, and also enables the EU to report as a single entity towards the UNFCCC. What you'll see is that we have around 72 long-term strategies to date, or LT-LEDs reported to the UNFCCC. And some countries are on their second long-term strategy. So you'll see here on the far right in the top corner, the long-term strategy in the United States. That's the strategy published under President Joe Biden. And of course, on the left there, the net zero strategy, the UK strategy, published by then Prime Minister Boris Johnson. But you'll see a number of different states now in different areas, small island states, large developing countries, emitters submitting these strategies as well. So this is really becoming much more popular within the UNFCCC. So what we did is we looked at these strategies and really assessed how they treat residual emissions and CDR in the long term. So when it comes to residual emissions, this is a term that's been used an awful lot lately. It's cropping up in various different climate policy frameworks. I like to think of it as in terms of state or date. So residual emissions may describe a quantity of emissions that continue to enter the atmosphere at the point of net zero. That could be carbon neutrality in terms of only CO2, or net zero greenhouse gases, or what the EU calls climate neutrality, which is balancing out these residual emissions of multiple greenhouse gases, converting to a similar metric with the removals from either land or what's often called novel or engineered carbon removal. You could also have residual emissions in terms of a date. So perhaps you have an emission reduction target, you don't have a net zero target, many countries still do. You could speak of residual emissions in 2050 in terms of sort of the residual amount left over after a program of measures has taken place. Meanwhile, hard to abate, these are often used synonymously. So people speak of residual hard to abate, or sometimes both. That's how the IPCC uses it, residual hard to abate emissions. These hard to abate is about the character of the emissions themselves. So this may be speaking towards its economics, the fact that we don't have sort of economically viable mitigation options for certain emission sources. It may also speak of the technical characteristics of those emission sources themselves. So what's often called process emissions in some sectors, which we can come on to. But focus on the right, this is a sort of diagram of what residual means in terms of net zero. So this is residual at the point of net zero, which is those gross emissions from all other sectors are balanced out by land use removals or removals from novel CDR. And that's a transition from, of course, the state today, where that balance is not as favorable towards removals, and certainly not in terms of emission reductions. So I hope you may have seen a diagram like this before. It's within the IPCC. This is our edited version. And what you can see is that we've gone through these strategies and collected some various interesting data points, then harmonized them into a single data set. So we're tracking the gross emissions, the gross residual emissions at the point of net zero, excuse me, and then also the land use emissions or land use removals, what's commonly known in the inventory language as LULUCF, essentially just meaning the land use itself. Of course, then novel CDR in terms of removal. So this is primarily bioenergy with carbon capture and storage in these strategies, or direct air capture and carbon storage as well. And also we do try our best at looking at sectoral residual emissions as well. So not only the total, but where those emissions come from in terms of sectors and sources. So the sort of main caveat I want to sort of premise some of our results with is that not many countries actually speak about residual emissions. And this is surprising when we compare not only the amount of strategies that we assess 71 in this case, but also the sort of multitude of net zero targets that are currently in place by national governments. 149 of the 195 parties of the Paris Agreement have a net zero target or a form of net zero. All of that implies some element of residual emissions and some use of carbon removals. But what we found is actually many countries don't speak or assess within their scenarios that they put forward in these strategies what that balance is, and therefore we can't necessarily assess their extent or nature of their residual emissions. So only 26 of the 71 actually included an estimate. We should caveat in saying that there are some countries that have strategies that are already net negative. These tend to be small island states or some states in Latin America. And so by their latest assessments, they only periodically assess their emissions at a national scale. They suddenly find they are actually net negative. They often have a small economy in terms of its industry compared to its land use. And that favorable balance means they devise climate targets that are quite different to net zero. They'll often be focused on reducing gross emissions further whilst ensuring economic development in the near term. So let's walk through some examples of residual emissions. Here's our timeline, and here's our historical emissions going forward. And 94% there is, in this example for this country, the decarbonization to date compared to peak emissions. So when a country peaked, excluding its land use removals. So these are emissions across all other sectors of the economy, energy, transport, waste, industry, etc. So in this case, this country peaked in 2018. And then we can draw and assess through looking at their strategies and their scenarios. So this country puts forward about 4 different scenarios, their residual emissions. And what you can imagine here is a negative side of this axis, where those values are balanced out by similar removals in land use or novel carbon removal. So these are the residual emissions. So you can see that actually, compared to peak emissions, residual emissions for this country vary between 36 to 52%. So quite high. Here's the rest of the data coming through. So on the top row, you have within our sample of developed countries that we have data for the top 4 countries with the highest residual emissions. These are the least ambitious in terms of reducing emissions across their economy. You'll see some examples like Australia and Canada, which have quite high proportion of residual emissions, but then it quickly tails off when it comes towards Iceland. On the bottom is the countries, the top 4 developed countries with the lowest residual emissions. So these are the most ambitious in terms of reducing emissions across their economy. You'll see here there's some very, very low emissions, so 7% in the case of Spain. The UK actually has 5% and has long continued this steady decline in emissions since the 1990s. A lot of these are European states, and the European emissions as a whole turned around in the financial crisis and started declining. So that's the sort of picture for the top 4 and the bottom 4. Here's a more compact way of showing this. So instead of having years along the x-axis, what we have here is a vertical format. So the progression down the graph represents the emission reductions at different points in time. The blue dots, again, of course, being the decarbonization to date, and the green dots representing the residual emissions. So across the whole, out of 16 developed countries that we have in our sample, the mean reduction is just shy of 80%. So a fifth of peak emissions is left over as residual emissions at the point of net zero greenhouse gases. Nevertheless, there's quite a large range within there. There's, of course, countries like Australia and Canada that we saw in the previous slide that have not only multiple scenarios, but some that are very unambitious. And these scenarios rely overly on direct air capture, in some cases international offsets, to achieve net zero greenhouse gases without reducing emissions that much across their economy. But a lot of EU states have emissions between 5 to 15% of peak emissions, so reductions in the order of 85 to 95%. The non-X1 countries that you see on the right are a much more mixed bag, and that's because often this sort of category of countries includes small island states, quite large developing states, and those have quite unique economies often. So you see in Cambodia and Ethiopia, in the case of Cambodia, because of its large land use sink and high rate of deforestation, it can actually increase its emissions across the rest of its economy if it stops its deforestation and transforms its land use sink. So we see some oddities in terms of even direction of the pathways isn't necessarily down for all of the other emissions in the economy beyond land use. Ethiopia is a similar case where there's quite a small industry, but quite a lot of land use. And so doing the same again means you don't have to reduce emissions much to achieve net zero greenhouse gases. Again, of course, there's quite a variety there, but the message is quite consistent for developed countries. So let's look at sectoral emissions. And I think the classic candidate for residual emissions, particularly hard-to-abate emissions, is industry. And the IPCC often speaks of three main emission sources: steel, in this case, cement, and also chemicals. And all those industry sources are residual hard-to-abate because of either economics or often because of process emissions. So cement, for example, in the calcination reaction, releases CO2. So our current way of making cement releases CO2 without necessarily combusting fossil fuels. This is what's captured in the industry category. And so what we see on the left here is not all countries submit sectoral residual emissions. Some only assess a total. So Canada, the US don't have sectoral residual emissions in their long-term strategy. But the rest do. And what we see is that as a proportion of total residual emissions, industry are around a fifth of those emissions. Now, when it comes to their emissions today and how heavily these scenarios mitigate industry emissions, we'll see that for the Annex 1 countries, so on this right panel, it's around about 70% from our most recent data, which is in 2021. So quite heavily mitigated in this case. Now, what's interesting is that whilst industry is the focus of the IPCC and a lot of literature around residual and hard-to-abate emissions, what we see in our scenarios is quite a different picture. What we see is a real dominance of agricultural emissions. And this is quite sizable in some cases in terms of the portion of agricultural emissions as a total, the total residual emissions. It's around 36%, so well over a third in this case. And that remains so for developing countries or non-X1 countries. In terms of mitigation, the mitigation ambition for agriculture as a whole is much less, only 37% from current levels. So a real mixed picture when it comes to what we often think of as the classic residual and hard-to-abate sources towards what's often spoken less about, which is agriculture. Of course, here we're assessing net zero greenhouse gases, so we end up with a lot of agricultural emissions that are methane or nitrous oxide beyond simply CO2. So this goes to show a sort of continuation of that trend that perhaps we're overlooking agricultural residual emissions in these in sort of overall literature and specifically within these strategies themselves. So here, what we did is we tracked every single statement across these 71 strategies in terms of when they mentioned a particular source or particular sector as residual hard-to-abate. And here's our comparison for those same two sectors. So you'll see quite a classic sort of spread for industry 232 statements in total. You'll see cement reduction dominating that proportion. Also F gases, these are fluorinated gases that are often associated with refrigeration or different foams within building materials, for example. These are often also treated as residual. But of course, industry contains a multitude of emission sources. So partly this isn't necessarily a fair comparison because there's so many sources to talk about in the industry category, but nevertheless, they are spoken about quite a lot. What's telling is that when it comes to agriculture, despite it being a much higher proportion in terms of the scenarios that we assess within these strategies, when it comes to actually detailing what is residual about them, the specific sources within that, there's very little mention at all. Only 72 statements, and most of those just mention agriculture in general. So we're not speaking about the part of the major issue, which is livestock emissions, which is the majority of emissions within the agricultural sector today. So that's quite telling and suggests that perhaps we're overlooking these emissions in terms of agriculture. So I wanted to end with this comparison. These are two different pathways, including the removals in this case, that reach net zero greenhouse gases. And these are both pathways within our support strategies. One is based on Portugal's climate law, which is the left one. Here, what you have is a 90% reduction upon its peak emissions across the rest of its economy, and then scaling up of its land use towards historic levels to balance out the remainder. So here, Portugal projects that they will reach net zero greenhouse gases, they'll achieve their target between 2045 to 2050. And this is a case of split targets. So CDR advocates often talk about the need for split net zero targets, so having a goal for both the removals and also the emission reductions across the rest of the economy. The one on the right is Canada's high engineered CDR scenario, so one of the least ambitious scenarios included within their long-term strategy in terms of emission reductions across the rest of its economy. Here you'll see that although these countries peaked at a similar time, Canada's emissions have sort of flatlined since, and those emissions are only reduced by just over half until net zero greenhouse gases. Meanwhile, the land use is scaled up towards, again, a bit like Portugal, its historic levels, so its maximum in this case, around 100 megatons. What you see here is the mass scaling up of these novel methods. This is primarily direct air capture in the case of Canada. And here we go from the levels we have globally today to a level that's 130 times the current level. That's all within just over 25 years. And so this goes to show, we often speak about mitigation deterrence, this risk that including CDR with the toolbox of climate measures incentivizes perhaps lesser emission reductions across the rest of its economy. And I often think some of the charges of mitigation deterrence are about trying to remove CDR off the table of sort of mitigation options. That's often, I think, an incorrect thing to do. IPCC speaks quite fondly in terms of it's necessary to include carbon dioxide removal in these pathways. But here we have quite a clear example of this mitigation deterrence, at least within the scenarios. Of course, whether a country actually follows these pathways is quite a different matter and quite a different question. So a real risk here, and it goes to show perhaps the need for these split targets to really make sure that we get the emission reductions across the rest of the economy correct. So within the paper itself, you can find the paper, you can scan the QR code here, which I'll leave up for a moment. We explore various different sort of policy solutions. We explore the idea of having sort of phase out norms. So it's often in the electricity we speak of phasing out coal. We talk about phase in norms. Can we tie residual emissions and CDR together within these climate policy frameworks in terms of what is reasonable to compensate in terms of CDR and residual emissions? Talk about the need for split targets and also the need for innovation to really drive down what we mean in terms of these residual emissions. So, of course, then the sort of overlooking of agriculture as well. So I encourage you to go read the paper if you can. There's a write-up as well on Carbon Brief, which I think contains some of the results as well. So do go and read that if you can. But yeah, quite happy to answer any questions. I know that was sort of a run through of what the main narratives of the paper, and the paper is chock full of other details as well. So happy to answer any questions. Thank you.
All right. Thank you so much, Harry. So yeah, let me just ask you a couple of questions at the outset, and then we'll move to audience questions. So one thing is when you're talking about agriculture and the fact that it's usually not acknowledged in the hard to abate emissions, why do you think that is?
Mm. Yeah, this is the question that naturally came from our results, and I think the honest answer in terms of our research team that put this together is we're not too sure. I think when we looked at some of the policies that were included within the agricultural sectors of these strategies, they often speak of making livestock more efficient, certain breeding practices, changes in methane inhibitors, so trying to improve the digestion of these livestock. There's very little suggestion of demand-side policy. Sometimes it's alluded to. So Italy has this great statement where we actually looked at the statement of why such an emission might be treated as residual. And Italy has this great statement where they say, look, we can do two things. We can improve our technology and drive down our industry emissions further, or we could ask people to change their diets. And these were seen as equivalent within their framework. So it's quite telling in our view that governments sort of see it as part of their sort of prerogative, duty, that they don't necessarily touch things as contentious as dietary change or demand side shifts. But of course, we do across many other parts of the economy. Transport is an obvious one where we change the demand patterns of many people in terms of cities and design and such. So, yeah, part of this we sort of suggested, is there a need, therefore, to talk more specifically about residual emissions? They need to say, look, this is our residual emission. If we don't include these demand side shifts, this is where we can go a bit further if we include these demand side, and perhaps we can innovate on top of that. And what we've seen recently is a number of papers that come out that adopt this kind of similar framework. So they'll turn up the dial in their model in terms of sort of technical changes to industry sources, for example, and they'll also turn up the dial in terms of societal changes. And perhaps they have them together or compare the two. But I think that's an approach that we need to adopt here in terms of these strategies. But yeah, agriculture definitely falls into that sort of demand side category where governments are quite unwilling to touch.
Could it be then as a corollary? I know there's another study out recently that talks about the fact that you could, there's a number of things that they look at on the demand side in terms of reducing agricultural hard to abate emissions. And one of their assumptions is reducing meat consumption by 80%, right, over the course of the next 3 or 4 decades. Given I think the incredulity of many, myself included, that could ever be a practical policy, do you think that agriculture may indeed, if purely from a political standpoint, be truly one of the hard to abate sectors, right, where we're not going to wring out a lot more in terms of emissions reductions? Or do you think there are things that from a political perspective are possible at this point that are substantive?
Yeah, certainly. And I should add that I fall into that category as well. I'm a meat eater currently, and I was quite shocked by the results. And I'm looking into reading books on the agricultural sector and sort of trying to understand it more. I think our language around residual and hard to abate emissions is often about technicality. We speak so often of industry sources because of the technical barriers to their abatement, right? The steel process, the cement process, the fact that lots of chemical products use fossil fuels as feedstocks. So agriculture, though, is not technical, right? So we can view sort of some of the breeding practices as essentially making livestock more efficient, similar to what we would do in terms of efficiencies elsewhere in the economy. But it's not a technical box. As you say, it's quite social and it's quite political. when we were writing this paper, the EU farming protests kicked off, and lots of the farming movement came to Brussels and the European Commission. We protested the agricultural policies that were aimed specifically at trying to mitigate greenhouse gases. So perhaps, this is about expanding our language as well. Residual emissions are hard to abate because of certain political and social logics, in addition to the economics and the technicality that's often sort of credited to these sources. I think in the case of agriculture, it's more of the social political than necessarily the technical.
Yeah, it's interesting. You group, I think you group countries between those that are least ambitious and most ambitious, right? In terms of the requisite or the level of hard to abate emissions that they project. Is it possible that those that are deemed to be most ambitious are lying? Could it be that you've got a bunch of people that are just overclaiming what's possible, and some that are being wholly realistic? Is there any way to sort that out by looking at whether, for example, the countries that have low amounts of hard to abate emissions have actually put policies and measures in place that ensure that path, as opposed to merely claiming that they're going to get there and maybe making themselves look good?
Yeah,
It's a cynic in me, right? Based on
absolutely.
my experience in climate regimes, it has to ask that.
Yeah, absolutely. And the cynic in me sort of shares that view in some sense. I'm sort of very fortunate in terms of the UK has had this really steady decline in emissions, and so it tends to boast in its politics that's you know we reduce emissions most in the G7, these kind of claims. And then I like to remind policymakers here that you have done very well in energy. You split from coal to natural gas, and then from natural gas to renewables. Your other sectors have flatlined or increased, right? So there's sort of no rest for the weary in terms of kind of policy. But you're right in saying, say you take a country that has a 90% reduction, like in the example that I showed at the end, we should really look under the hood of that scenario to assess what assumptions are going on, and are those assumptions realistic to historic trends? That's what we do in some of the scenarios that are assessed in the IPCC, for example. They often filter against some of the historic patterns, and they say, does this scenario, this model, ramp up things too quickly beyond the realm that we've seen in past technologies, for example? And a lot of that work now is filling into CDR. So we say, what's our maximum potential CDR if we ramp up CDR, direct air capture, for example, in a similar sense to solar? And we can answer that question, and then we can begin to tie these assumptions together into more realistic scenarios. Often these scenarios are what they call backcast scenarios. So they're attempts to ratchet up your model to reach your net zero targets, and they compare it against your current policies, and you say, this is our emission gap. A bit like what we do for the main emission gap report that's released every year. And so these have a function that's very specific. But nevertheless, I think we should begin to look at these. And begin to look at not only feasibilities in terms of ramping up a lot of CDR very quickly, but also feasibilities in terms of some of the social innovations. Like you say, is it reasonable to suggest that you can reduce meat consumption by so much? We should really look into that in terms of research. It's quite what we sort of advocate in the paper is, once we understand what is residual and why, we should begin to follow those things into these research and into these policy areas. So residual as a sort of category is not too useful because it combines all these different sources and sectors, quite different barriers to their abatement. So let's start looking at those individually.
Yeah, I think that's going to be really important from a standpoint of accountability and transparency, right? Going forward, and kind of the ability of folks in the NGO sectors and others to put pressure on certain countries, right, that are probably overclaiming what's hard to abate. So I have a question in that context, probably not a fair question, but I'm wondering if it's one that you've looked at or you contemplate looking at? Because it's one I keep wrestling with when it comes to so-called hard to abate emissions. Okay. Um, what what are the metrics that we should use in deeming something truly so hard to abate that we should give country a pass and let them balance those emissions with carbon removal and other emissions that we should be pushing countries to actually reduce, whether because there's co-benefits from doing so or whatever, right? And how do we establish those kind of metrics, right? When do we know that it truly is impossible, or it would cost so much money, right, that we don't want the countries to have to do that? How do we set those metrics? How much is too much money, right? Because it might
That's
be
it.
in certain sectors that if you spend just a gobsmacking amount of money, you can reduce emissions, but we can't realistically expect that. But we might expect
Mm,
them to spend 10 or 15% more, right? Given the benefits of reducing emissions as opposed to relying on carbon removal. But how do we set those metrics?
yeah, absolutely. And it's something we wrestle with as well. And I know there's been work around, like you say, are there a group of emissions that are really truly hard to abate that are simply off the table in terms of mitigation? Often the candidate for that is certain fertilizer emissions from agriculture,
Hmm.
because we're sort of backed into a nitrogen corner in terms of our food supply. Um, so that's sort of seen as off the table. So that would be balanced out by removals in the land sector, for example, in a lot of these scenarios. But when it comes to price, what we actually looked at for a lot of these statements that describe a source and then a reason why they're residual hard to abate, is when we track that over time and produce a sort of series of rationales, cost wasn't that important. And so no matter sort of what technology you sort of pick, countries sort of pick their winners and then say, look, the cost curves are going to be favorable by then. So we often speak of cost in terms of residual emissions because of things like integrated assessment models and carbon prices and how those models are assessed. But there's very little barriers to cost. There's very little appeals to cost in general in these strategies. Often it's more political. So there'll be certain path dependencies in infrastructure. They say, look, we just can't turn our steel sector around quick enough, no matter how fast we build and how fast costs decline. So, of course, then you're trading off with a ramping up of often novel CDR. And so
Hmm.
you're comparing technical trajectory to technical trajectory, which is more feasible. That's a question that I'm not well placed to answer, but it's an interesting one and one that people have started exploring. I should add that there were some real interesting examples of countries then defining residual emissions and residual emission conditions. So Switzerland does a great job of saying, look, unlike Canada, where there's a lot of fossil fuel emissions balanced out by removals, no emissions in 2050 will come from fossil fuels that could be abated by a known mitigation option,
Right, like Sweden is doing
including,
that, right?
yes, certainly Sweden's climate policy framework is quite unique in terms of it sort of removes some of its land use component, says we'll get to 85% reduction no matter what, and then the rest will be balanced out with these different measures. Um, so yeah, there's a beginning of what we term in the paper a phase-in norm. So countries begin to tie their conditions down as to, okay, this is what's feasible, this is what's definitely bad in terms of practice. Therefore, can that principle be a sort of guiding light to some of our scenario generation? And that often has some engagement with costs, of course, but not as much as we anticipated. We expected, given our sort of review of the literature going into this paper, for this all to be about economics, and it's not necessarily the case.
Yeah, yeah, that's interesting. So okay, let me move to a couple of questions that we have.
Mm,
Uh, let's see. First question from Emma Bromark says, I work with agricultural emissions, and in my bubble, my
mm,
experience is extremely common to just casually state agricultural emissions, often very, very general, as residual or hard to abate. I would have
mm,
not guessed that it's shadow in terms of industrial emissions, but maybe that's the thing. It's so generally accepted as a residual emission sector that it's not viewed as interesting to discuss in policy. I think that
Yeah, yeah, absolutely. Um, I think agriculture is somewhat flown under the radar. Often these scenarios that we assess in the IPCC, for example, they do everything at once in terms of mitigation. And that's not how countries actually approach mitigation at all. Countries do it sector by sector. And you can sort of view this as like areas of climate policy. We've just gotten the energy sector right, right? We're not fully there in terms of
hmm
our electricity grids, but we know how to get there and we know we're going to do it at a pretty reasonable cost. In fact, it might actually be favorable in most cases. So there's very little place for fossil fuels in the future electricity grids. Now we've turned to, I think, probably transport and industry is our main focus right now in terms of climate policy, particularly speaking here about the EU and the United States and the UK. We speak a lot about sustainable aviation fuels when it comes to transport, electric vehicles, transforming green hydrogen in terms of reduced steel, transforming cement with circularity in different materials, chemicals in terms of bio-based chemicals instead of fossil feedstocks. So we're seeing a wave of sort of new plans around industry. Industries, many countries are now coming up with hydrogen roadmaps, cement roadmaps, industry sort of industrial strategies. Agriculture again is still sort of trudging along. It's sort of stable in most cases. It's we've managed to balance out the increases in emissions with gains in efficiency in many cases. But we'll come on to it eventually. I think it'll be one of the last sort of sectors we come across once industry has been sort of starting on its way, a bit like energy has. So that's my sort of best explanation as to why you um, why you often get that sentiment of it's residual, it's hard to abate.
hmm
People just there's a categorization people do. And part of this paper is just surfacing that categorization in these national strategies and saying, okay, is that useful? Is that a useful way of thinking about climate policy? I'm not sure it is, but we have to deal with reality no matter what we do.
Yeah. No, I think it can be valuable because I think beyond some of the solutions, as I said, probably just aren't tenable, like reducing
Mm,
meat consumption for better or worse, right? Or some of the other behavioral changes. There are probably things that can be done to wring out some of those emissions, right? And we probably
mm,
should be trying to push that sector as much as we can, right?
mm,
To early on, right? Because the longer we wait probably to push that sector, the more we're going to be relying on CDR, right? That
mm.
it may not happen. So it's interesting.
Yeah,
So next
absolutely.
next next question, Marlene Ramon Hernandez. Uh, is there not an inherent risk in counterbalancing permanent emissions with impermanent land-based sequestration activities? Surely there can be a move toward organic fertilizers, a diet shift to free up land and reduce demand, et cetera. Well, just what you're talking about.
Mm.
So what do you think about that first part? Is there a risk of counterbalancing so permanent emissions, or what's often called, geologically based emissions, right,
Mm.
from fossil fuels with short-term, maybe nature-based emissions reductions?
Yeah, I think there is. Um, our former paper was really on this topic, and we looked at
hmm
the CDR the components of these strategies. And what we found is that when countries talk about net zero, they're mainly talking about balancing residual emissions from a range of sources, not only what we call some of the biological greenhouse gases, so methane, for example, which has a shorter atmospheric lifetime, um, and not only that, but also, of course, fossil CO2, which has a much longer lifetime, with these with general land use, essentially, with their land use sink. Generally, that sink is big enough in many countries to it's impermanent when you shrink it down to the sort of forestry level. It's permanent more or less when you talk about the nation state. But There are examples where, for example, Portugal's emissions peaked in the year it did because of mass wildfires across its forests. So there are cases where that's not necessarily true. It depends very much on the size of the country. Take Canada, for example. That's probably a case where these are, in terms of the scales we talk about in terms of assessing climate change, these are more or less permanent in terms of national accounts. But nevertheless, there's this quite sort of prominent voice towards geological net zero. So here, fossil CO2 we balanced out by permanent carbon dioxide removals, often from these engineered methods. And I think that's a good step. I would like to see that in terms of some of our work around CDR. The risk is that it's quite a big step from what we have today.
Yeah.
It's a huge shift in climate policy, and I don't think the advocates of that concept necessarily appreciate that. We've fought about land use since 1997 in climate policy,
Yeah.
where a lot of the original concerns were about mitigation deterrents from land use, not from novel carbon removal.
Yep.
So now it's all about direct air capture and some of these sort of new startup methods, perhaps even a shift around marine CDR and concerns there. But the original concerns were around land use and undermining the Kyoto Protocol. And there's debates around that, but it was quite a problem. The US in the negotiations said, we must have land use in our accounts because it makes our emission balance so much more favorable as a country. So I share that view, but I just think in terms of adopting a like-for-like principle as a universal metric for all countries in the UCCC, I think that's quite a long way off. What we'll see is innovations in net zero targets that make them more feasible and more or less match this like-for-like principle. So take Sweden that we mentioned previously. Sweden says, let's discount a lot of our land use sink, which is very sizable. Sweden's almost at net zero already, just net zero greenhouse gases. Let's discount that because that's not us doing climate policy. Let's do everything that's additional to that existing land sink in terms of improving the land use sink balance. And then that could be one option to balance out residual emissions, which must decline by 85%. The other could be BECCS, because we have a lot of, we have a quite a large bioeconomy in Sweden, or we can help other countries through Article 6. Those are our three options for balancing out residuals. In that case, you have a framework that looks much more like the like-for-like principle, but with some flexibilities. So I think we'll get into seeing a lot more targets like that in the future, I think.
Okay. Next question from Dan Gelpern. Aren't there other decent sources of information or data to enable sectoral analysis of residual emissions from nations like the US, for example, that didn't report details on their long-term strategies under Paris?
Yes. And in fact, a lot of this we use, and my former sort of role in the UK was the work on the detailed national accounts for emissions. And these are huge undertakings that go into very abstract and hidden away databases on the UCCC. I've never seen the light of day. Thousands of pages of research go into estimating different emission sources. But that's to track our historical emissions. So part of my work in the UK eventually was tracking everything from large power stations down to squirty cream. So quite a variety. But most importantly, when it comes to UCCC strategies, these countries often have the freedom to present their results how they wish. And when it comes to CDR, there's no guidance of how to do this. And so the sort of political sort of opportunity for these countries to say, look, we fulfilled our obligation submitting a long-term strategy, but a lot of the details will keep under the hood. And there's a reason why they might do that. The EU, for example, doesn't really, in its strategies, it won't reveal its distribution amongst the member states because that's political. And it's quite different towards about negotiation between the member states. In the same sense, lots of Russia's long-term strategy stops short of its net zero targets because they say, well, what's the political benefit of us revealing and tying ourselves into a certain emissions balance? Australia does a similar practice. In fact, Australia's long-term strategy was nicknamed the Planflit. It was called the Plan. It was called the Planflit in Australian climate politics because it was so thin and so poorly communicated in terms of scenarios. So they actually artificially stopped their scenario short of 85%. But fortunately, we can find their net zero scenarios, very hidden appendix that they include. So yeah, there are better sources, certainly historical emissions. When it comes to future emissions, we're interested in national governments and their view. We're sort of stuck with what we have, which are these LTLEDs that are quite variable, to say the least.
Yeah. Do you think ultimately when you're citing evidence of mitigation deterrence, right? And I think there's other evidence of this also. Um, do you think at the end of the day, this idea of dual commitments, right, in terms of emissions reduction and then carbon removal, is the definitive solution to this, or does this have to be done in conjunction with other mechanisms? How do we stop mitigation deterrence in its tracks? Because I think not only is it dangerous, but I think from a political standpoint, when we look for support from such as the NGO world, right, it undercuts support when they start seeing palpable mitigation deterrence, right, that's consistent with the theories out there.
Yeah, absolutely. And mitigation deterrence is, yeah, I have colleagues who sort of research this, and it's quite hard to find in terms of definitive proof of
Right.
mitigation deterrence.
Yeah.
It's not the example we showed at the end is one example, but it's an example in a policy plan that has very little weight in terms of its national politics in Canada, for example. So it's not necessarily a scenario that's being followed. It's one option of many. But perhaps the fact that the option is on the table is an example of the potential for mitigation deterrence. So often mitigation deterrence is used as this kind of critique of the political economy of CDR. My interest particularly is looking for mitigation deterrence within climate policy. So can we find this within, for example, the design of emission trading systems, where a lot of CDR is coming into discussions with the ETS, particularly in the EU and the UK. The UK just released its consultation on the matter. Depending on how you design your cap, may mean that you end up with less emission reductions across the rest of your economy in terms of these ETS sectors. So it's either quite a general critique, which is often used by NGOs, somewhat rightly, somewhat wrongly. It's quite a mixed picture. But searching for mitigation deterrence within specific examples in climate policy is quite hard. So yeah, I don't think split targets necessarily. I think split targets are one very easy step to do. I'll give you a sort of cynic answer, Will, which is that those that have split targets or have innovations in their net zero target that sort of do the splitting concept are the countries that have a pathway that's quite clear and have quite an easy ride to net zero already. So they sort of find out their emission balance is a lot more favorable than perhaps they sort of initially started with. So Finland's a good example of this, where its targets moved very rapidly forward because they actually found their bioeconomy is very good at BECCS all of a sudden. And it makes sense, right? So whether it's notable to us that those countries with very high residual scenarios in this paper are those that have economies that have essentially flatlined since. So it comes back to your point before about this kind of realism versus ambition debate. It's quite hard to tie down. But nevertheless, split targets are not, as a political solution, it's much more messy because we'll see split targets adopted by countries that have a favorable pathway already. As a advocacy position for the CDR community and NGOs, I think it's a good thing to keep sort of banging the table about these need for split targets, because it ties us into more intelligent pathways around these debates around residual emissions and around these debates on emission reductions, etc. So it gets us onto more useful ground, I think, by advocates.
Yeah, yeah, and I think again establishing realistic metrics, right, for what's truly hard to abate. could help us to do that, right? And I'm not sure whether those come voluntarily or they're developed as international standards or national standards. But I think until we get to that point, we're still going to have the potential for that kind of mitigation deterrence, right? And
Mm,
that
absolutely.
could be
It'll
worrisome.
be it'll be an ever-present risk throughout CDR, I think. So it's something we need to be wary of. But I don't think it should stop us from asking the questions of CDR itself. So it's an interesting one. I definitely don't have the answers.
Yeah.
But metrics would be great.
Yeah. Yeah, well, hopefully we'll start seeing them.
Mm.
So where does your research go from this? Is there a natural extension beyond what you're currently looking at?
So this sort of paper rounds out a lot of our work on these long-term strategies. So before, in the sort of what you loosely call the climate tracking space, so things like the emission gap report, state of CDR, which is a sort of tracking addition to the CDR space that fits into these wider sort of gap reports, as we suggested at the beginning. We observe in that space that there's very little discussion of these long-term strategies, but they're quickly adding up to quite a sizable sample.
Right.
So we wanted to put them on the table as saying, are these documents useful to analyze? Are they useful to keep tabs on and assess? There's some interesting work following on, which we can't say too much about, but it's essentially, can we, instead of tying our assessment of climate progress to a fair share pathway, which often goes into these debates of normative, what's the normative share for these countries? When do they need to reach net negative, for example? Can we tie their current climate progress to their residuals and therefore tie a ramping up of their, how much do they need to ramp up their emission reduction rate to meet their residuals that they themselves self-state they need to reach in terms of their net zero target. So perhaps that's a much easier way to tie countries into a more progressive emission reduction pathway without necessarily going to these messy areas of negative fair share commitments, etc., which are important, but I think also quite difficult to solve in the UN apparatus. So we're publishing a data set that will be publicly available on our tracking of these strategies for other people to use. And then following on from that, we're looking at the UK. So we have a study going on. The UK is sort of missed out of a lot of the discussions of CDR. We have the mighty work of the IRA in the US and the DAC hubs, which is extremely interesting in the CDR community. We have the EU's CRCF, the Carbon Removal Certification Framework, which is the EU's first steps. The UK is sort of this in between that's doing some interesting stuff, but we don't talk about it that much. There's some interesting pilot projects. There's some new funding mechanisms. The UK will be the first to include engineer CDR within its ETS specifically in terms of its design.
Right.
Japan has done some steps, and New Zealand obviously has a forest ETS, but UK will be the first to try and do what the EU might eventually do. So the EU is quite keen to keep tabs on that. So we're interviewing a range of stakeholders in that study to really find out where's the UK going. UK has a really interesting strategy because it really needs to rely quite heavily on engineered CDR because we have a very small land use sector. So will be quite I view the UK, I'm somewhat biased because I'm of course based in the UK, but as a litmus test for a lot of the engineered CDR policy efforts, because we might make the mistakes that a lot of countries may need to avoid. So see what happens.
Yeah, I think it's interesting too, especially given the fact that there's very little available quote unquote novel CDR at this point, right? To start premising a lot of what you're going to get in terms of meeting your goals with that, right, is a leap of faith. But it may be a reflexive leap of faith that drives demand that ultimately brings more supply online as a consequence. So it can be salient. But I agree. I think the UK doesn't get enough coverage in this context. So maybe we'll have you back on when there's more substantive developments. So with that, with that, we have reached the top of the clock, and I would once again like to thank.
Here is your reminder.
Oops.
Pick up dry cleaning.
I'd like to
Just
once
let me
again.
know if this is
Yes,
done.
I know. I'd like to once again thank you for joining us, and thanks to all of our audience. And we'll be back in a couple of weeks to discuss initiatives of the Department of Energy, including the first U.S. government procurement program, as well as the U.S. government's efforts to establish contours for responsible carbon removal. So I hope many of you can join us then. And once again, thanks everyone. Goodbye now.